This screencast is going to cover ternary compounds. Ternary, you hear the 3 in that, it is any compound with 3 or more elements, and it must contain at least one polyatomic ion. So polyatomic ions are defined below: 2 or more elements that work together as a single unit of charge. Most of what you have on the negative ions are all forms of polyatomic ions. There's only one positive polyatomic ion, and that's this guy here, NH4Cl. So all the rules that we used for writing the other formulas work the same. The only thing now is we have to keep this unit together. So there's a key anytime there's more than one, so not one, but more than one, parentheses are used to isolate that ion. So your first example with that is calcium plus 2 with OH minus. So we're still doing crisscross or reduce, or least common multiple of 2 and 1 is 2, so I need 1 calcium and 2 of OH as a group. So that means there's 2 hydrogens and 2 oxygens in that formula. Again, this one doesn't look wrong when you don't have the parentheses, but without the parentheses it will be marked wrong. If we get a one that's a little more complex, this is iron plus 3 and sulfate minus 2. You'll see that the charges were crisscrossed. And you wouldn't write SO43. That would look wrong, and you'd put your parentheses in to isolate those. You just have to be careful with hydroxide and cyanide. So cyanide would be the same thing. So if we were doing strontium cyanide, we'd have strontium plus 2, cyanide minus 1. We'd have to crisscross and get SRCN2. Okay. The one that is up there at the top, the NH4, that is your only polyatomic ion. That's a cation. So NH4 is a plus 1, Cl is negative 1. So again, plus 1 minus 1 cancels each other out. The thing you need to realize is on these polyatomic ions that you're memorizing, anything that you're memorizing as a group, so like the NH4, the SO4, that number never changes. It never moves, it doesn't get crossed, it doesn't change. So if you're memorizing something as a group, it always stays together. All of the other units, or all the other rules for writing polyatomic ions work the same way. This time you're just doing the name of the cation plus the name of the anion. So this one we figured out was plus 3. I'm going to go back up to this example. The reason I can figure that out is I can undo the crisscross, so kind of go backwards. This only works if the charge that's here is the charge of your SO4. Okay. So again, that's one that's sort of like the crisscross and reduce that's dangerous. The one that always works is doing your multiplier. 3 times minus 2 gives me minus 6. So my formula has to be plus 6 because this has to be a neutral compound for the number of electrons lost to be equal to the number of electrons gained. So again, this tells you SO4 as a group gains 2 electrons. Again, same meaning as we had with single atom ions. Single atom ions is the same here. So if this is plus 6 and this is 2, I have to take 2 times plus 3 to get plus 6. So that's how I know that this one is iron 3 sulfate or ferric sulfate. Okay. Chromium is in your next formula. This is also a bivalent metal, so we have to figure out what the charge of it is. And it's not chromium 4, so the 4 from the PO4 is not going to go back. It's not chromium 1 because there's no crisscross to reduce, or crisscross to undo. So you need to be really careful with this, so you'll always want to check what the charge on the anion is. So PO4 is a group that you should recognize as phosphate, which is a negative 3 ion, and if that's negative 3, there are no parentheses around this formula, so that tells you there's just one of that group, so it's minus 3. So to be neutral, the total on chromium has to be plus 3. Again, there's only one, so this is chromium 3. Phosphate or chromic phosphate. Okay, since we already did number 1 on the previous screen, I'm not going to do that one again. So the next one you have is aluminum with nitrate. Again, you'll see NO3 is a group in parentheses, so you know that's one name. Aluminum, if you look where it is on the periodic table, doesn't have a D block, so there's no other name for it, so it's just going to be the name of the metal, which is aluminum in this case, and then NO3 is nitrate. For number 3, since I didn't leave enough space here, I'm going to work down. Usually I work up. SO4 is a group, it's -2, so since you see that 2 matches the ion that you have here, so let me write this one here. So as soon as you see that that -2 matches, that can go back here, then you know that you can undo this, and that this is cobaltic or cobalt-3 sulfate. As we're delving into more of these polyatomic ions, I did want you to take a look at some patterns here for these. Just like we had with the metals, you had the IC and OUS endings, which mean higher and lower numbers. You're going to see this as well here. So you'll notice that the ITE is always the lower number of oxygens in the formula, and the ATE is the higher number. Notice it's not always the same amount. Now the nice thing is both of your -1s, your chlorate and nitrate, have the same number, and then your -2 just increases 1 to 4 for the ATE ending, but they don't mean the same thing. So spelling will certainly count for these ions when you're writing them as names. And ITE and ATE tell you it has oxygen with it. So when you have just the single ion, this is going to be chloride. So the phrase I use is "I'd rather be alone." So when you see "I'd," they're by themselves. So Cl- is chloride, N-3 is nitride, and S-2 is sulfide. So any of these, because there are patterns you can predict from the periodic table, may also be on the quizzes for the -1 and -2, -3 ions. Now, chlorine has another case with it. Since there are 4 different combinations with oxygen, we have to have a way to distinguish all 4 of them. So we already have the iron-8 used. We have the hypo for the one that is 1 lower than the normal ITE. And you might remember from osmosis, hypotonic cells don't have enough water in them, where hypertonic has too much, so hypo means lower. Or maybe you know hypothermia is when your temperature drops really low. So if you think of the lowest number of oxygen has the hypo with it. Okay, and then the higher number of oxygen, so 1 more than the ATE, has the prefix per with the ATE ending. So it's really important that you pay close attention to those as you're doing problems that deal with these ions. Okay, you also need to be able to write these formulas from names. So cobaltic is CO+3. Carbonate, again, tells you the ATE has oxygen with it, and you should see the stem of the name of the element. So this is carbon and oxygen, and it's CO3 - 2. So again, least common multiple is +6, or crisscross and reduce in this case. So my 2 is going to come here, my 3 is going to come here. And this 3 is different from this 3. This first 3 that I underlined here is the subscript for carbonate, so it has to stay the same. So I'm going to have CO2, and then CO3 is going to be in parentheses, and I need 3 of that entire group in order for my formula to be correct. The next example is potassium oxalate. Again, potassium you can get from the periodic table, which is just K+ because it's in group 1A. Oxalate is sort of a strange ion, so you're going to find there's a bunch that have carbon in them, and none of them are real easy to memorize. I did have a student give me one for this one, and this is sort of strange, but I'm just going to write this off to the side. Trying to use the names, trying to make a connection here. So if you see, so there's your C, 2 cows, and you should have 4, then 2 ox are late. So you're missing 2, so minus 2. And then you have the name oxalate. So if you can kind of put that together, I know that's a lot of steps, but it gives you a way to memorize those wacky ones. So getting back to our +1 and -2, so again, potassium is just a single element. You're just going to crisscross here, and you're going to get K2C2O4. Now I did this one because this is one where crisscross and reduce does not apply. So oxalate will never reduce. You have to have that C2O4 in the formula. You can't divide out those two because you wouldn't be able to name CO2 as a group. You may know CO2 is carbon dioxide, but it's not an ion that stands alone. For our next example, we have zinc. Again, notice there's no Roman numerals for that, so that one is filled D block is just +2. And then hypochlorite is that ClO negative. Okay, this is another one you have to be careful with parentheses. So I'm going to crisscross or do least common multiple, and that's 2. So I need just 1 zinc, but I need 2 of this whole group. So ClO needs to be in parentheses with a 2 outside for that formula to be correct. Okay, you'll have a practice sheet to work on with these, so please make sure that you complete that as directed.